Hello, everyone. Our project is titled Determinants of Academic Success, a Socioeconomic and Demographic Analysis. In this project, we explored how demographic, socioeconomic, and behavioral factors influence student academic performance using machine learning models. Our main research question was, to what extent do socioeconomic and demographic factors predict student academic performance? We were motivated by the idea that educational success is influenced by more than intelligence or effort alone. Factors such as parental education, attendance, and lifestyle may also contribute significantly to student outcomes. By identifying which non-academic factors most heavily influence grades, educators can better implement targeted intervention programs for at-risk students. We use the UCI Student Performance Dataset, which contains academic and demographic information from secondary school students in Portugal. The dataset included variables such as parental education, absences, alcohol consumption, study time, and age. Our target variable was G3, representing the student's final grade. Before training our models, we cleaned and processed the data. Categorical variables were converted using one-hot encoding, and numerical variables were normalized. Importantly, we removed intermediate grades G1 and G2 to avoid data leakage, since they're extremely strong predictors of the final grade.
So we implemented four machine learning models. Uh, we used linear regression that was our baseline model. Ridge and lasso regression helped address a multi-collinearity and overfitting through regularization. Finally, we used a random forest regression to capture more complex nonlinear relationships and compute feature importance scores. To evaluate our models, we use several metrics. R squared, as you can see, measures how much variance in student grades is explained by the model. Mean square error and root mean squared error measured prediction accuracy. This metric being squared makes it especially useful because it identifies whether our models are making inaccurate large predictions by penalizing large outliers more heavily than small ones. We also applied a five-fold cross-validation to ensure our results were stable and not dependent on a single train test split. This provides us with a more realistic estimate of how our model will perform to unseen and new students. The CV standard deviation ensures the measure of consistency of these results. So we essentially trained four separate machine learning models on the same process data set and compared their predictive performance using evaluation metrics such as the ones you can see right here. So this is our results among all evaluated models. Uh, Random Forest was the best one. It achieved the best performance with the highest R score and the lowest prediction error. However, even the best model explained only about 18% of the variance in student grades. This suggests that academic performance is influenced by many additional factors that are not included in the data set. Linear, Ridge, and Lasso focus more on linear relationships. Random Forest captures nonlinear relationships and interactions. That's why Random Forest slightly outperformed the others. This is our graph for the root mean square error. As you can see, Random Forest has the lowest score, so that means it's the best performing model. Same with R squared. You can see Random Forest has the highest score. And here with cross validation, uh, yeah, you can see, yeah. And then feature importance. Uh, these are the 10 most important features in random forest. And here's the correlation heat map of all of those features. Yeah, thing.
I can do this. Okay. So this study also have several limitations. So the data set only represented two students from two particular schools, so the results may not generalize to other populations. Additionally, important factors such as motivation, mental health, family income were not included in the data set. And also some data was self-reported, which may introduce bias or, or inaccurate results. Finally, although removing G1 and G2 help prevent data leakage, it also reduces the predictive accuracy of our models. So, in conclusion, our study shows that the academic performance is influenced by multiple socioeconomic and behavioral factors. It's by a combination of academic history, attendance, behavior, and lifestyle factors, for example. And among the evaluated models, random forest regression achieved the best predictive performance, suggesting that a nonlinear relationship exists between those variables and student outcomes. However, the overall predictive accuracy remained moderate, indicating that academic success is highly complex and influenced by many additional factors that were not included in this data set. And then future work could improve the study by using larger data sets, additional socioeconomic indicators, more advanced machine learning techniques. Yeah, and that's it. We can show our code. And yes, so this is where we get our results and in the table with model performance metrics such as linear regression, ridge, Russell, and random forest. And this is the top 10 important features. And we put the model inside a file with PNG, which is where we get most of our uh, figures. For example, feature importance and a correlation heat map and all the comparison images.
Thank you.